Ever wonder what makes the sun shine so bright? It's not magic, but science. A process called nuclear fusion. This phenomenon takes place right at the heart of our sun and indeed all stars. Picture this, small atoms like those of hydrogen coming together in an epic dance. As they combine, they create heavier elements, releasing a colossal amount of energy in the process. This energy is what we see as the sun's brilliant glow, a celestial light show powered by fusion. Now consider this. The same process that lights up the cosmos could potentially provide a clean, limitless source of energy right here on Earth. No more drilling for oil, no more burning of fossil fuels, just the pure, unending power of nuclear fusion. Imagine if we could replicate this star power on Earth. Sounds like a dream, right? Creating a star on Earth isn't as easy as it sounds. To achieve nuclear fusion, we need to recreate the conditions of the sun's core right here on our planet. That means generating temperatures of over 15 million degrees Celsius and exerting immense pressures, far beyond anything naturally occurring on Earth. But the challenges don't stop there. Once these extreme conditions are met, we have to maintain them long enough for fusion to occur. That's like holding a piece of the sun in your hand without getting burned. Scientists around the globe are working tirelessly to overcome these hurdles. From the ITER project in France, aiming to demonstrate the feasibility of fusion power, to the National Ignition Facility in the US, conducting high-energy density physics experiments, the race is on to unlock fusion's potential. Despite the challenges, the rewards of harnessing fusion energy are too great to ignore. The promise of clean, limitless energy keeps us pushing forward. What fuels fusion, and why is it a dream come true for our energy needs? The fuels for fusion are lighter elements like hydrogen isotopes, deuterium and tritium, to be precise. These isotopes are abundant here on Earth, particularly in seawater. Imagine an energy source where the fuel is virtually limitless and readily available, a stark contrast to dwindling fossil fuel reserves. But it's not just about abundance. The real magic happens when these isotopes come together. The fusion process combines these small atoms, releasing a colossal amount of energy. We're talking about a power source that's millions of times more potent than fossil fuels. And the cherry on top? The process leaves behind no harmful greenhouse gases or long-lived radioactive waste. So, we're looking at a power source that's plentiful, potent, and clean. It's like striking the energy jackpot. Fusion energy is not only powerful but also clean and sustainable, a stark contrast to our current energy sources. Nuclear fusion is not what you think. It's different and safer than nuclear fission, the process used in nuclear power plants today. To understand how fusion is a safer alternative, let's first clarify the differences between fusion and fission. Nuclear fission, currently used in power plants, involves splitting large atoms like uranium or plutonium. This process, while effective, can be risky. It generates a significant amount of hazardous radioactive waste and carries the risk of a meltdown, a catastrophic event if things go awry. On the other hand, fusion, the process that powers the stars, involves combining small atoms, typically hydrogen isotopes, to release energy. It's a process that happens naturally in the heart of the sun, under intense pressure and heat. The safety advantages of fusion are considerable. It produces negligible radioactive waste and carries no risk of a meltdown. The fuel used in fusion is abundant and readily available, reducing the need for hazardous mining operations. Fusion offers us a safer and more efficient way to generate power, a true game changer. Imagine a world powered by fusion. What would that look like, and how close are we to this reality? Picture this, cities of the future humming with clean, limitless energy. Cars, homes, factories all powered by the same forces that light up the stars. Fusion could potentially drive a technological revolution, transforming how we live, work, and play. But how close are we to this reality? Scientists around the globe are pushing the boundaries every day to bring this star power to Earth. While it's a challenging endeavor, the progress is promising. A fusion-powered future might not be as far off as we think. As we wrap up our journey into the world of nuclear fusion, we're left amazed by its potential to light up our future. And here's that cool fact. Scientists believe that fusion reactors could one day power spacecraft, taking us further into space than ever before.